Hi everyone, welcome back. More on index laws. I've done index laws playlist if you want to have a look at it with numbers. Now we go to the algebra, which is where people muck up. So let's have a look at the first one. There are simple rules I can talk to you about, but I'm not going to talk about the rules right straight away. I'm going to talk about what does y squared mean. Originally, back in the beginning, all I have decided was that y squared meant, I'll put it over here, it just means y times y. That means y times itself twice. Then there's another multiplier here, and then we've got another multiply y by itself 3 times. So we've got a y times a y times a y. I can still remember at school when I first did this, having to think that through a fair bit until one day it sunk in. Then I can go, that's 1, 2, 3, 4, 5 of them. So that's actually by the only rule I made up was that's a y to the power of 5. So you might notice there's a shortcut, and the shortcut is that little 2 and that little 3 will add up to 5. This is only adding those if you're multiplying. Let's have a look at another one. So this one here, that in the long way, what I call writing out in the full. I wrote that out in full, that means m times m, and then we've got another m here. So what have I got now? M times m by its definition, by the rules they made up, is m with a little 3. So here's the scary part is, I'll often write that in the test, and a lot of students will put m squared. It's like the concept of understanding what's going on here. If you multiply by something extra, it can't stay the same. So for example, if m was 10, this would be 10 by 10 is 100. And if you multiplied it by another 10, it wouldn't be still 100. It would turn out to be 1,000. Remember, ladder's only about replacing numbers so we can solve real life problems. So we're learning the rules that we're going to apply to real life problems. So look at what I call the baby numbers. That little 2 up there, little 1 up there, I call them baby numbers. The baby numbers we're going to do addition. 2 plus 1 is 3, and that's one of our index laws. So when you're multiplying, look at the rules, when you're multiplying, the bases stay the same. So I have this thing I nag about, bases stay the same. In math, we call the number or the letter down the bottom here the base, just like you've got a base to a light stand or the base of anything. You can have a base of something as a part down the bottom. So rather than saying the bottom, I'll commonly refer to as bottom, but the bases stay the same. Let's make it a little bit more complicated. So it's similar to these, but we've got some extra numbers. So between any two things in math, it means multiply. So I've got a 3 multiplied by something. And then m squared by definition is get an m times another m. Then I'm multiplied by a 10, and then I'm also multiplied by another m times m times m. So if you look at what's going on, the 3 and the 10, because you can multiply in any order you want. For example, 2 times 3 is the same as 3 times 2. Both will give you 6. You can multiply in any order you want, as long as it's all multiply. So now I'm allowed to go to 3 times the 10 is a 30. And then I've got 1, 2, 3, 4, 5 of those. So that's my m to the power of 5. So we use words like index, power, and America and a lot of other countries use exponent, but they talk about being an exponent of 5. Let's look at the shortcuts. This is a normal 3 with a normal 10. So they just go normal everyday multiplication. 3 times 10 is 30. And then you can go to the baby numbers or the index. And what do you do with when you're multiplying and you've got an index of 2 and an index of 3? The m stay the same, those m's stay the same, and you add the powers. So that's index law, but you add the powers when you're multiplying. So that's just a 30 m's to the 5. Some of you will be okay now, so I don't need any more. So let's just do a couple of quick ones. Without writing it out in full, I'm allowed to go the normal 3 by the normal 2 is a 6. Now this y really has a power of 1 on it. So using the indices, when you're multiplying, you add the powers, but the base stays the same. Always remember the base stays the same. So I've got a y to the power of 3. So you've multiplied by an extra y. So instead of having y times y, you've now got another one. So let's shortcut it even further. 10 sevens are just 70. And then you add the powers. So the normal numbers are okay, and then the baby numbers, I call them baby numbers, and then babies can add, then using are able to multiply. So 5 and the 4 is a 9. What if we add extra things in? As long as it's all multiply, we add extra terms, extra letters, extra numbers in. This is a 2 times a 3, and this is actually a 1. 2 times 3 is a 6. Now we've got a 3 power, a 2 power and a 1 power all on the wires. So I've got 3, 4, 5, 6, so I've got 6 wires of the 6. Hope it helps. I'm going to do a bunch more, and each time I'm just going to go a little bit harder. And sometimes people think, I'm right, I'm okay, I don't need to look at the others. Probably a lot of people by the time they got to here were okay. Quick look at those. But the extra videos now, I'll show you all the things that people get wrong in assessments and how we can make them harder. If you enjoy it, please let your friends know.